Hi everyone, today we are going to start 8.5, which is use properties of trapezoids and kites. A trapezoid. A trapezoid is a quadrilateral with one pair of parallel sides. So if we look at our diagram here, we see these triangles. Remember, those triangles mean that those lines are parallel. The two parallel lines are called the bases. So we have a base here and a base here. The other two sides that are not parallel are called the legs. An isosceles trapezoid. An isosceles trapezoid is a trapezoid with congruent legs. So here are our legs, and we see with those tick marks that those two legs are the same length. Theorems with isosceles trapezoids. Number 1. If a trapezoid is isosceles, then each pair of base angles are congruent. What that means is if we look at these legs, we see that they are congruent with those tick marks. It means that our base angles, or these two lower angles, are the same measure. Number 2, if a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. So that means if we know that these two base angles are congruent, we then know that the legs are congruent because it's an isosceles trapezoid. Number 3, a trapezoid is isosceles if and only if the diagonals are congruent. So we have our isosceles trapezoid, those legs are congruent, meaning that our diagonals are the same length. And vice versa. If we know that the diagonals are the same length, we then know that we have an isosceles trapezoid. Find the measure of angle B, the measure of angle C, and the measure of angle D for both these problems. Let's look at number 3. We see that we have an isosceles trapezoid because of those tick marks. So if angle A is 53 degrees, what would be the measure of the other base angle? Well, it would also be 53 degrees because they are congruent. So angle B is equal to 53 degrees. Now we need to look at angle D. If we look at angle A and angle D, we can clearly see that they're not congruent. We have one acute angle and one obtuse angle. But this is a quadrilateral, which means it's a shape with 4 sides. So we talked about before that the consecutive angles in a quadrilateral are supplementary, meaning that they add up to 180. So if I know the angle of A, the measure of angle A, and I need to try to find the measure of angle D, I'm going to add up those two angles and set them equal to 180. So let's call angle D x, and I need to solve for x. So here we go. I know that 53 plus x is equal to 180. Subtract 53 from each side. We end up getting that x is equal to 127. So that means that angle D is equal to 127, which also means angle C is equal to the same thing. Angle C is also equal to 127 because angle B and angle C are also supplementary. Now that I found all the angles, I can move on to the next problem. So number 4. Once again, I see that I have an isosceles trapezoid because of those tick marks. So those legs are congruent. So I know that angle A is 97 degrees. So what is the measure of angle D? Well, it would also be 97 degrees. Now looking at angle B, we know that they are supplementary. So if angle A is 97, what would the measure of angle B be? And the answer is 83. And if angle B is equal to 83, what is the measure of angle C? It is also 83. Midsegment of a trapezoid. The midsegment of a trapezoid is the segment that connects the midpoints of the legs. So we know that this point would be the midpoint on our segment here, and we see that because of these tick marks. We know this point right here would also be the midpoint of that leg, and we see that because of those tick marks. So the segment that connects the two midpoints is called the midsegment. Midsegment theorem for trapezoid. The midsegment of a trapezoid is parallel to each base. So this line here we know is parallel to the top base as well as the bottom base. Once again, that's what those arrows mean. And its length is 1/2 the sum of the lengths of the bases. So what that means is that if this was 10 and this length was 20, and we wanted to figure out what is the length of our midsegment, we would add up our two bases, 10 plus 20, and we would divide that by 2. So when we plug that into our calculator, 10 plus 20 is 30. Divide that by 2, we would get 15. Now remember that midsegment should be a number in between your two bases, so it should always be greater than the small base and smaller than the large base. All right, use the midsegment of a trapezoid. We want to figure out what is the length of MN, and so we will call that X. So we know that to find X, I need to add up my two bases, which in this case is 12 and 28, and then divide that number by 2. That will give you X. So plug that in your calculator, and what do you get for X? You end up getting that 20 is equal to X. All right, let's try this again. Find the value of X. Now, if you look at these problems, we notice that we know what the midsegment is, but we're trying to figure out what is the base. So when I set this equation up, I'm going to do the same thing that I was doing before where I add up the bases, where in this case, one base is 4x, the other base is 16. I'm going to divide that by 2. And we know what the midsegment is equal to, and it's equal to 12. So now I just need to solve for X. So to get X by itself, the first thing I want to do is get rid of that division of 2. And to get rid of division, I'm going to multiply by 2 on each side so that those cancel out. So then I have 4x plus 16 is equal to 24. I'm going to subtract 16 from each side. 4x is equal to 8. Divide by 4x then is equal to 2. Now let's double check that our answer is correct. So I'm going to plug x back into my equation for this base here. And when I do so, I end up getting 8. So if I use my midsegment theorem once again, is 8 plus 16, divide that by 2, is that equal to 12? And it is. So I know my answer is correct. All right, now let's move on to number 20 here. I noticed the same thing, that I know the midsegment, which is 20, but I don't know what one of the bases is, so I need to solve for x there. First step is to add up my bases. One base is 17. My other base is 7x minus 5. Then I'm going to divide that number by 2. We know that that's equal to my midsegment, which in this case is 20. So my first step here is I need to get rid of that division of 2. So I'm going to multiply by 2 on each side. So multiply by 2, multiply by 2. Those cancel. So I'm left with 17 plus 7x minus 5 is equal to 20. I have like terms here, the 17 and negative 5, so I can combine those together. So 17 minus 5 is 12. Then I have that plus 7x is equal to 20. Subtract 12 from each side. I am so sorry. This should be a 40. This should be a 40, right? Because I did 20 times 2. So this is a 40. I'm going to erase this and make it a little bit cleaner. So what I really have is 12 plus 7x is equal to 40. All right, now I can subtract 12 from each side, and I get that 7x is equal to 28. Divide by 7, we end up with x is equal to 4. Now, let's double check that this is correct. If I look at my bases and I plug x back into this equation here, I end up getting that that is 7 times 4 minus 5, that's 23. So 17 plus 23, divide that by 2. Do we get an answer of 20? And we do, so that means that our x value is correct. Next, we're going to talk about a kite. A kite is a quadrilateral that has two pairs of consecutive sides that are congruent, but the opposite sides are not congruent. When you think of a kite, think of the one that you fly in the air. So it looks like this. And so the consecutive sides are congruent, meaning that this side and this side are congruent, and that these two sides here would be congruent. Notice that the opposite sides of a kite are not congruent. That's what we're used to with the parallelograms. So that means a kite is not a parallelogram. So here's some properties of kites. Number one, the diagonals are perpendicular. So, and one of the diagonals will be bisected. So if I draw that out here, I have these two diagonals. They are going to collide at a 90-degree angle. That's what perpendicular means. And if you look at the diagonals, it tells us that one of the diagonals will be bisected. So which diagonal would be bisected? It would be this one here, the shorter diagonal. And then our next property is that exactly one pair of opposite angles are congruent. So that means that these two angles here would be the same measure. Now I do have a little formula here about area. You don't need to memorize this. You don't really need to know it. But if we're trying to find the area of a kite, we're going to take the lengths of the two diagonals, multiply them together, and then divide them by 2. We want to find the measure of angle D in the kite shown at the right. Okay, so looking at our kite here, we see that this angle is 115, and we see that this angle is 73. Looking back at our properties of kites, what do we know about angle D and angle F? Well, we know that they are the same measure. Now, we don't know what measure they are. That's what we need to solve for, but I can call each of these angles x. So our goal here is to solve for x. Since we have a quadrilateral, what is the sum of the interior angles of a quadrilateral? That would be 360 degrees. So now I'm going to set up an equation of x plus 115 plus x plus 73, and I'm going to set that equal to my sum, which is 360. So let's combine our like terms. I have an x plus x, which we know is 2x. I also have 115 plus 73. If I add those up, I get 188 is equal to 360. Subtract 188 from each side. I end up getting that 2x is equal to 172. Divide by 2. Divide by 2. X is equal to 86. So the measure of angle D then would be 86 degrees. In our last problem, use theorem 18 and the Pythagorean theorem to find the side lengths of the kite. Then write the lengths in simplest radical form. So knowing our properties of a kite, if I figure out what this side length, I would also know that side length. If I were to figure out this side length, and I'll call it y, I would also know that side length. So let's solve for x and y here. If I start looking at x, notice that we have a right triangle here. So I'm going to redraw this triangle. And I know that the height is 4, the length is 2. I need to figure out what is the hypotenuse. To solve for x, then, I'm going to use the Pythagorean theorem. So I have 4 squared plus 2 squared is equal to x squared. So 4 squared is 16. 2 squared is 2. We know that's equal to x squared. So 20 is equal to x squared, but I don't care about 20. I don't care about x squared, I care about x. So to get x by itself, I need to square root each side. So the square root of 20 is equal to x. Now it did ask us to write our answer in simplest radical form. So what perfect square number is divisible by 20? That would be 4, and we know 4 times 5 is 20. So I can rewrite the square root of 20 as the square root of 4 times the square root of 5, which we know is equal to x. Which one of these radicals simplifies, the square root of 4 or the square root of 5? It would be the square root of 4, and we know the square root of 4 is 2. Square root of 5, or radical 5, just stays the same. So that is what our x value is equal to, 2 square root of 5. Now if we wanted to write this as a decimal and to simplify this, we know that x then would be approximately 4.47 if you plug that in your calculator. All right, next, so now we know one side. We know that this side here is 2 radical 5. We also know that this side is 2 radical 5. Now let's solve for y. So once again, I have a right triangle, and I'll sketch this out. So we know this is 2, this is 6. I need to solve for y this time. So 2 squared plus 6 squared is equal to y squared. 2 squared is 4, plus 6 squared we know is 36. That is equal to y squared. So 4 plus 36 is 40, and that's equal to y squared. However, we do not care about y squared. What we do care about, though, is figuring out what y is. So I need to square root each side. And so the square root of 40 is equal to y. We need to simplify this into simplest radical form. So which perfect square number is divisible by 40? It would be 4, and we know 4 times 10 is 40. So I can change the square root of 40 to the square root of 4 times the square root of 10. We know that's equal to y. The square root of 4 simplifies to 2. Square root of 10 stays as the square root of 10. That's equal to y. And if I wanted to simplify to square root of 10 with a decimal, I know that that is approximately 6.32. So now if we scroll back up, I know that this side length is 2 square root of 10, and this side length is 2 square root of 10.